Okay, so for 7th grade, we're looking at Chapter 8, Section 4. And so today we'll begin to talk about some geometry things. So we're going to talk about segments, and then tomorrow we'll get into angle bisectors. But today it's segment bisectors. So segments are what? When you hear that word segment, do you have an image of it? Raise your hand if you do. You don't have an image of a segment? You don't know what that means?
Oh, yeah.
Well, see, we got to start there. So what is a segment, Zach?
It's a line with one side that doesn't continue. The other side goes on in one direction.
Okay, so he says it's like a line that continues in one direction but not the other. I don't see agreement all over the place. Who thinks you can refine that a little bit? Michael?
It's a line that ends on both sides.
So it's not a line, actually, is it? I mean, it's like a piece of a line. A segment is a piece of a line that has endpoints, right? 2 points and all the points between them, a segment. So when your teacher asks you to go get in a line, are you really in a line? You're in a segment. Your teacher should say, go get in a line segment, right? Because whoever is at the front and the back, those are our endpoints. And when you're supposed to be in a line, you know, like I was mentioning on the fire drill, sometimes you're not looking like a line, and you know what that means. You're like a big old crowd or whatever, right? So congruent, the word congruent is a super important math term. What does it mean? If you have segments that are congruent, what might they be? Sarah? The same shape and size. Good, and congruency means same shape and size, but since it's just a line, it would be, I guess, the same length, right? So that's, I guess, our definition. Segments with the same length are congruent segments. So a way to write that would be like this. We have a little symbol for congruency, which looks like an equal sign with a wavy line above it. And a way to state the name of a segment would be to state its endpoints, AB. Segment AB with a segment on top. Notice there are no arrows on the ends of this little segment. And when you're little, sometimes they put big old dots at the end of those, you know? It's like endpoints. So this is saying that segment AB is congruent to segment CD. Can we say that together? Ready? Segment
AB is congruent to segment CD.
Good. And then this is something different. But don't they look alike?
Yeah.
Right?
Yeah.
But you don't see the little line above the letters here. And you don't see the wavy line. And so what this means is, if I measure that segment, I would actually have a number, right? Measure it, and if segment AB equals 5, then this says the measure of AB equals the measure of CD. So if AB was 5, what would CD be? 5 as well, because they are congruent. Okay? So that's how these two things differ. This one is saying, oh, I've got congruent things. Think about the shapes and sizes like Sarah said, right? And then this one says the measures are equal. The numbers are equal if I measured them. Okay? Midpoint, next term. Well, midpoint, now those are pretty common words, right? What is mid short for, Sabrina?
It's short for medium.
Well, medium begins M-E-D. Did you know that? But medium is related to this. That's true. But mid might be short for something slightly different. Mid. Could you finish this word, mid?
Medium?
It's a 2-syllable word. 2 syllables. You said the same word again. And Jonathan. Middle. It's kind of a funny word to say slowly. Mid-dull. It's dull. Anyway, midpoint is the middle point of a segment, right? So could somebody give me another way to define that? How would you know you have a middle point, midpoint? Jeremy?
The halfway point.
Halfway point, good job. So you could measure, right, and confirm it. Point that divides a segment into 2 equal segments, okay? And when you're watching a video, if you need more time, pause it, right? So that's what we're going to do today. We're going to talk about what might divide a segment into 2. And if we have a segment with a midpoint, what could we say about that segment. So we're going to use a midpoint today. Not a hard concept. So you'll have to pause here and write this stuff down. Draw the picture of segment OD. And then we could also call this segment DO. And then M, as it says, is the midpoint of segment OD. We also are given a couple of dimensions. We're given 80, which represents what small segment here? Izzy. 80 is what small segment?
Um,
80 is the length of O to where? Nope. It's to M, okay? So good. I want to make sure you understand. 80 is O to M. And what is the length of M to D, Bailey? M to D. What do they give you? 16x. Do you see that? 16x. What's the operation there? Multiplication. So 16x. So with this amount of information, we should be able to find x. And how might we set up an equation to find x? We are told M is a midpoint. So how might we set this up? Sophia.
80 equals 16x.
Very good. She says 80 equals 16x. I don't even think I have anything under this screen here, so let me get rid of it. Okay, and how did you find that, Sophia?
Well, they're equal sides.
80?
16x.
Okay, and that's because she started with this in her head. She didn't say this out loud, but she said OM equals MD. Thumbs up if you saw that too. Did you see that too? And why is OM, this distance, equal to this distance here? Why is that true, Casey?
Midway.
Because M is the midpoint, right? And that means it's halfway between those two endpoints. So once you have this equation set up that Sophia gave us, you can solve it. And go ahead and solve it. And okay, and Mary, what are you doing to solve this?
Divide 16 by 80.
You're dividing 16 by 80?
Or 80 by 16.
80 by 16. So what are you dividing 16 by? Over here.
16.
Okay, so on the right, she's dividing 16 divided by 16 to get 1, right? So she must do the same division on the left side of the fence, or the equal sign, right? And what do you get, Mary, when you do that, you know?
5.
She says 5. Who agrees? 5. Very good. And you can check that out by plugging it back in, right? You can plug it in here, and 16 times 5 equals 80. It's true. Okay? So go ahead and find x in question 3 and question 4. I'm going to ask for a volunteer to come in and show us this. Who has not been up here during math? They're not seen. Whoops. Okay, she did an awesome job. She says AM equals MB. So then she plugs in AM is 7x. MB is 35. To get x isolated, she divided both sides by 7. And x equals 5. Now everyone take notice of these little red lines. This is a geometric notation, a way to write something in geometry. If you want to say that a line is the same length as another segment, I should say segments, right? A line segment has the same value as another segment. You can put a dash on one segment and a matching dash on the other. And when you do, now you've told the world that these two segments are equal. Okay? And they could have put 2 dashes. They could have put 2 here and then 2 here as well. But if you see a figure that has 1 red dash here and 2 here, it means they're different. Do you understand? They wouldn't be the same. They have to have the same kind of dash. Okay? And now number 4. Pause the video, try it, come on back. How funny that we keep getting the same solution, right? But in order to test it, I could take this solution 5 and I could plug it in, right? Up here. What is 4 times 5?
20.
20 minus 5 is?
15.
So this side equals 15. And then what is 3 times 5?
15.
15 is on that side, so they both equal 15. Just as if we tested this one here, 7 times 5 is,
35.
and then this side was 35. So we are able to check our own work and know that we have the correct answers. Okay? Okay, go ahead and read this carefully and do it on your own. What does a person do when you have this kind of a question? Do what? Nico? Draw it. So draw a picture and then solve. Okay, so this is different because the entire segment is 20t, but we're actually asked to find t, and we know that xm half of the segment is 5. Oh, here's a hint for you. If I know that half of a segment is 5, do I know the other half?
Yes.
What is the other half? 5. So what would the whole segment be?
25.
What is 5 plus 5?
10.
10. Oh, yay. Okay. I know the whole segment should be 10. And so 10 equals what? Jeremy?
Well, I was a little confused.
10. Okay, I've got to get this answer. 10 equals, Lindsay?
20t.
20t. So there you go. Find Chad, what is t? Or how would I find it now?
I divided 10.
Well, if I have 20 times t, what am I going to divide by to get t alone? Okay, so if I divide that side by 20, I must divide this side by 20. So t equals, guess what? 1/2. And I hear some people say 0.5, and that's the same value, 1/2 or point. If we take 1/2 and plug it into this t here, what is 20 times a half? 10. And 10 is what we said this entire segment equals. So we are correct. Okay? Okay, we're going to talk a little bit about another type of segment bisector. We already saw that a point could be bisecting a segment, cutting it in half, right? But there are other things that could cut a segment in half. Can you think of any? But a segment bisector is anything that cuts a segment into 2 halves. So here we have a lot of choices, as we were just saying. It could be a point like we saw, or it could be a ray, like Ray Gazzo, yes. Or it could be a segment, a line or a plane. It just happens to be cutting it into or at the midpoint. And if it's a perpendicular bisector, it's special because perpendicular bisectors form what? Okay, so perpendicular bisectors will bisect a segment forming right angles, like a T. Okay, so we're going to have to pause and draw this image and answer the question. Can you identify the segment bisectors? So you'll have to pause, draw these points that you see and all the ways that they connect and extend, and then we will identify what kind of segment bisectors we have. Okay, so we have segment NP, line ST, line LM, line QR, and then all these different points. V is the point where these are all intersecting here. There's a little box here, there's a little dash here, and a little dash here, which we've talked about already. Okay, so NP, we're asked, is NP a bisector? So let's look. NP. For LM, look at LM. Here's LM. And what I suggest is use your eraser. Just kind of travel over gently. You know, is that LM is here, NP is here. Is NP a bisector of LM? Yes or no?
No.
No, they're not even intersecting, right? They're not even intersecting, so the answer there is no. How about line ST? ST, and it says it's a line, arrows on both ends. ST. Is ST, this line, bisecting LM into 2 congruent segments? Yes or no?
Yes.
Yes, it is. And it is because I can see that L to V and V to M are congruent due to these dashes. So ST, line ST is a bisector. Finally, QR. QR, is that bisecting segment LM? Yes or no? Yes, it is. Good job. It all came down to the symbol that shows us that LM has been bisected.